Welcome, everyone. We appreciate you taking time away from your busy schedules to join us today. My name is Tonya Levine, and alongside of me remotely is Chris Williams. I am the Director of Sales for the Noise Control Building Materials Group here at Kinetics Noise Control. And Chris is our Market Group's Territory Development Manager. We cover both the US and Canada, and our product focus are floors, ceilings, walls, airborne and structural-borne sound and vibration isolation. Today, we're going to be talking about a new product called MetaWrx. Meta can be defined as pertaining to a level above and beyond. We'll touch on why this isolation technology has earned the right for the name it's been given. This is a brand new product offered exclusively by Kinetics Noise Control. It was just released last week. We're going to make this webinar short and sweet today, for we know everyone's time is valuable. After the presentation is completed, we encourage you to share your ideas with us. We hope that this presentation gets everyone thinking where we can go with this technology in this wonderful world of noise and vibration control. Again, if anyone has any questions, please include those questions in the chat box, and we'll try to address those questions before we sign off here. If we do not get a chance to answer your question today, we'll reach out to you individually. I will now turn the presentation over to Chris Williams, where he will share about this exciting new product. Thank you, Chris.
Thank you, Tonya. So, what is this new technology in the world of sound and vibration isolation? MetaWrx is a new class of isolator offered exclusively by Kinetics Noise Control in a forward-thinking collaboration with engineers at Hyperdamping Incorporated. MetaWrx exploits a patented integrative structural material design to maximize damping when shock and vibration loads are transversely applied through the elaborate network of beams you see there to the right. Those design elements are rooted in research conducted at Ohio State University. A bit of a history. The founder and creator, Dr. Ryan Harn, had been working at the frontier of vibration and shock damping for 15 years when he suffered a traumatic brain injury from a fall on a hard floor that led to permanent hearing loss and nerve damage. He said, "Waking up in the hospital, one of my first thoughts was that if I had landed on a floor damped with superior vibration and shock damping materials, this could have been prevented." Thus, the hyperdamping technology emerges. As we know, Kinetics has been at the forefront of engineering airborne and structure-borne sound and vibration isolation technology for over 60 years. And in pursuit of continuing that innovation, Kinetics has come to recognize that a whole new approach to addressing composite floor buildups required innovative thinking regarding the architecture of an isolator, not just the media. So Kinetics connected with Hyperdamping Incorporated, and as a result of that collaboration, Hyperdamping engineered brand new architectural isolation technology to enable the exploration of various ways to address heavy impact on the structure, like barbell and dumbbell weight drops, CrossFit activities, dancing, etc., while simultaneously exploring ways to reduce the total height of composite floor buildups, yet achieve STC and IIC values associated with much thicker isolators, thicker floor buildups, and layers stacked upon layers of resilient underlayment systems. What makes this patented technology unique? It's the architectural design. So imagine that the isolator, spaced 12, 24 inches on center, will experience uniform load like that of a typical buildup between 1 pound and 50 pounds per square foot. So that beam network you saw a couple slides ago and off to the right here is designed so that when a uniform load is applied, the beams start to collapse under that load and elastically stretch in this synchronized direction at the bottom right. Each individual beam holds one another up from actually collapsing or post-buckling under the load. The fact that the isolator has this connectiveness prevents catastrophic motions and promotes high levels of shock and vibration mitigation. Let's watch a demo. So here we have our cylinder drop demonstration that honestly really displays the genius behind the beam architectural technology. So on the left here, we have an empty cylinder. All cylinders are about 2 inches in length and 3/4 inch diameter. In the middle there has the solid silicone rubber core. Then you take that silicone rubber, which has, by the way, an outer diameter very slightly greater than the inner diameter of the cylinder. It's about a 3% difference. And then you put this beam architecture into the silicone because now these beams are radially arrayed. They repeat circumferentially around the silicone core. And so what you're seeing or going to see are drastically different behaviors between the three upon impact. So there we go. What you're seeing are drastically different. Left bounces quite a bit, the middle bounces, and the right lands and stops. So like we mentioned before, what you're seeing there is critical compression near the elastic buckling point. The material is compressed just enough so that each of those radially arrayed beams are buckled but not post-buckled. Pretty impressive. There's a lot more to this technology than what you're seeing here, but this gives you a very good visual of the capability of this isolation technology. Let's look at some properties. So as we mentioned, 3/4 inch thick and about 4.3 inches by 4.3 inches. This is the first design of many, but for the heavy impact, it was found at the 50 durometer was the highest performing. And you can see there the material itself is a butyl rubber, which, as you may know, does help reduce the dynamic stiffness. And as you can see, this isolation technology reduces dynamic stiffness by about 40%. Now for the best part, the performance. So a little over a year ago now, Kinetics built out our first weight drop research facility. The development of this isolator, as you can imagine, required all sorts of testing, and we went through multiple design iterations, redesigns, and working with hyperdamping engineering team, we conducted heavy weight drops and accelerometer measurements on our in-house test floor setup. Of course, testing the usual load deflection and load natural frequency, and of course, testing for STC and IIC performance in the lab. What you're going to watch here are weight drops, of course, and there are a couple things to point out in the videos. The sequence will go to the left, the bare floor buildup, so no isolators. All the way to the right, you will see a video of the spring isolators, and centrally located is going to be the MetaWrx isolators. If you look at the bare floor buildup, you can see actual dust fly up with significant shock. The isolators, the mats actually fly up off of the platform, and to the left, I will play this video one more time. You actually see the accelerometer fly off the platform. And the MetaWrx weight drop, none of the above. So we'll watch them here and simultaneously. Videos speak for itself. So what you just saw there, the overall setup, drops were repeated 5 times for all test conditions, and the results, which we'll go over in the next couple slides, were averaged. So the buildup itself was 3 layers, 3/4 inch plywood, glued and screwed together, resting atop a 4-inch concrete subfloor with the isolators placed in between, the wood and concrete spaced 24 inches on center. We had the accelerometers underneath the slab there, as you'll see, and then resting up top on the platform. The weight drops themselves were 110 pounds, 200 pounds, and 290 pounds, all dropped from 30 inches. And then the 1-inch thick rubber mats were placed at the impact points. So first, the wooden floor vibration results. Here we have the data summary from the August 2021 weight drop evaluations, in which the y-axis shows the peak-to-peak max displacement in inches for essentially more convenience of understanding how much these materials actually moved. And the x-axis shows the weight of the weights. And if you remember from the diagram on the previous slide, the transmitted energy was measured via accelerometers both underneath the concrete slab, and the floor vibration was measured on one edge of the wooden platform. So the wooden floor vibration, spring isolators magnified the wooden floor vibration by as much as 3 times, as you'll see to the right there. And in every case, MetaWrx, represented by the light gray color, always reduced wooden floor vibration. So the least vibration is always achieved with the MetaWrx floor isolators. The shock transmission, the spring isolators provided slightly more reduction of shock than MetaWrx for 100 and 200 pounds, and about even for 290 pounds as we increased the weight. That said, on the other hand, the spring isolators, if you remember from the video, can lead to detrimental floor vibration. In other words, MetaWrx floor isolators are the best solution to improve both user experience in the facility and adjacent to it. We conducted a wide variety of STC and IIC tests at Intertech Acoustical Laboratories. 18 total buildups, 9 buildups with a 6-inch structural slab, normal weight concrete, and 9 tests were conducted with a 5.5-inch thick composite steel deck. So what's represented here is the structural slab. Our baseline test was the 6-inch structural slab with 3 layers of 3/4-inch plywood resting atop the slab. And that, as our baseline test, achieved an STC 52, IIC 49, and HIIC 54. We then took that same buildup and incorporated the MetaWrx isolators spaced both 12 and 24 inches on center. These numbers represent the 24 inches on center. Fiberglass insulation in the 3/4-inch thick cavity created by the isolator. And that jumped up to an STC 60 from 52, an IIC 61, so 12 IIC points there, and an HIIC of 67. Then we took that buildup, incorporated 2x6 lumber sleepers that are sitting on top of the isolators as shown there, and a finished LVT floor, STC 61, IIC 67, HIIC 82. All this information, all test reports, can be found on our website. To further the testing at Intertech Acoustical Lab, we did a before and after MetaWrx isolated buildup with 100-pound weight drops, and we measured the difference in sound pressure levels. So that top line represents the baseline buildup, so 6-inch normal weight slab plus 3 layers 3/4-inch plywood. Again, that's represented by that top red line. That was our first test. And the second test, we took that same buildup, as you saw on the previous slide, and we measured the difference in sound pressure with the 3/4-inch MetaWrx isolators and the R6.7 insulation blanket in between slab and plywood. And starting at about 63 hertz, you can see about a 5-6 dB difference as we get up to 125. And across the board, really, MetaWrx isolation technology achieved anywhere from about 14 to 18 dB in sound pressure level reduction. That equates to a 96.88 actual SPL reduction, and a 64.64% perceived volume reduction. And all that was achieved on a total of 3-inch buildup, including the 3/4 inch MetaWrx isolators and 3 layers of 3/4 inch plywood.
This truly is a design revolution that we believe will create multiple opportunities to design more low-profile floor systems using lighter materials for construction. Whether for new spaces, repurposing a space, or difficult remediation, MetaWrx offers design elements that help you achieve performance levels like STC and IIC, often requiring a thicker isolator or many more layers of materials. For more information on MetaWrx, please visit our MetaWrx webpage. There you'll find all of the test reports along with product information, drawings, and other details. Thank you for joining Chris and I today on this to go over this exciting new product. We hope that you will get as interested about it and you want to learn more as time goes along. And please contact us at the information available on screen. Thank you.